All right, our final presentation of the day comes from Mount Pleasant and Central Michigan University with Meier and using the Affinity Propagation to cluster socioeconomic census data.
Hi, good afternoon. My name is Meier. I'm from Central Michigan University. I'm a graduate student in their GIS program, and today I will give a presentation on my current research called the use of affinity propagation to cluster socioeconomic data. What I'd like to begin with is the question: what communities best represent the United States? When asking this question, it's a very broad question that can be defined in a number of ways. The way I chose to look at this question in particularly is what communities best represent the U.S., what socioeconomic characters of those communities, using the socioeconomic characteristics, what communities best represent the United States. I came up with a list of attributes, socioeconomic characteristics, as mentioned, that I thought best defined the people of the community. This is a question that I wanted to explore in my study. So to begin with, in order to find the most representative communities of the US, I looked at clustering the United States. And I came up with reasons of why we want to cluster the United States. First off, it would give us a better understanding of the heterogeneity of the US. Second of all, by clustering the United States, we can create ideal sample sites that can be used for future research, testing out new products, testing out new government policies. Any of the social studies that look at communities, they can use clusters to identify ideal sample sites. Advantages of sampling is we can take few geographic locations and we can expand the results from the studies done there into much larger geographic regions. It's a cost-effective methodology. By taking ideal sample sites, we're also making the assumption that these sample sites, the characteristics, can be expanded to other areas or locations within the same region. To begin with, I looked at some earlier studies that involved either finding sample sites or clustering the United States. The first one I took a look at was done by Lind and Lind in 1929. They conducted a study to explore the lifestyles within a customary American community. Their goal for their study, their initial goal, was selecting a sample site that represented the most common area of the United States. Now, you must note that this study was done, it actually began in 1924, they published it in 1929. Back then, they did not have the technology that we currently have today. They had to rely on different methods back then that we can otherwise do today. They did, however, use US Census data in the selection of their sample site. They factored in weather of the different areas. They looked at population growth. They looked at the industry of the city and the artistic life of various cities. They looked across mainly the Midwest, and they came up with Muncie, Indiana as their ideal sample site, which they deemed Middletown in their study. But most of it was done off of personal observation. But again, that's because it was conducted in 1929. Since then, advancements in data mining have been developed which can be applied to large data sets. Data mining, it involves analysis and extraction of patterns previously unknown due to the size of data sets. Recent developments in data mining and statistical algorithms, which are used in data mining, are creating solutions to problems dealing with large data sets. As I mentioned, the Lind study, they used US Census data. That's considered a large data set. A more recent study was done by John Robin. He came up with this computer program called PRISM. And what that did was it clustered US zip codes into 40 what he called lifestyle clusters. The goal for him was to come up with an effective marketing plan. He wanted to see if he could cluster the US into 40 lifestyle clusters and based on those clusters, determine an appropriate marketing plan for each cluster. There's a quote up here that he listed. It says, "Tell me someone's zip code and I can predict what they eat, drink, drive, even think." What his thought for that is if you can better understand a community, you can better understand the people within the community and their behaviors. So if you come up with a generalization for a set of communities, if you understand the characteristics of that community, you can make a prediction on how those people will act. He used it for marketing, what the people will buy, what products will sell well in that area. Later on, Michael Wise published a book called The Clustering of America. In his book, he looked at these 40 lifestyle clusters, but instead of looking at them from a business or a marketing aspect, he looked at the cultural aspects. How well did these 40 clusters represent the different cultures of the US? Finally, a more recent study was done by Ching and Gimple. They wrote a book called Our Patchwork Nation. In their book, their goal was to determine the different types of America. They looked at the social, economic, and political differences of the different locations. They used US Census data at county level. They also used political and economic data. A lot of the economic data came from the US Census. Their methodology for clustering the US was a principal components factor analysis. One thing to note, though, about their study is in the results, some of the counties fell on the border of being in either, let's say, cluster A or cluster B. For these particular counties, they manually classified the county into whichever cluster they felt most appropriate. They didn't leave it strictly up to the principal component factor analysis. So now getting on to my study, the objective of my study, first of all, was to map US Census sociodemographic data using affinity propagation to group zip codes into meaningful clusters. Not only that, one thing that these previous studies did not have is they did not identify exemplar locations. Yes, they clustered the US into different groups, but in my research, I'm hoping to, along with clustering the data, find exemplary locations of the US, which can then be used as ideal sample sites in future research. Another thing I want to do is, or what I did in the study, was I combined GIS techniques with a novel statistical analysis. And finally, I demonstrated an objective method for the generalization of large data sets. The statistical algorithm that I used in my study was called Affinity Propagation, as in the title. It was developed in Frey Labs at the University of Toronto. It's a clustering algorithm that expresses exemplars, which, as I stated, they're the most representative data points in the cluster, and they're actual data points that come from the data set. They're not averages or anything of that sort. They're actual data points. What it does is it considers all data points as exemplars. Unlike other clustering algorithms such as k-means sometimes starts out with like a randomly selected or a predefined. Affinity propagation does not do that. It goes through and considers all. The parameters for affinity propagation, it only requires two parameters. First of all, a dissimilarity matrix, which I will get into later. And then the second is a preference value. The preference value, it's a value that influences the number of clusters. It does not define the number of clusters. Like in the k-means algorithm, you put in the number of clusters that you want. In affinity propagation, the preference value, as recommended by the developers in Frey Labs, they recommended the minimum value from the dissimilarity matrix. You can alter the preference value. By increasing the preference value, you'll result in more clusters. By decreasing it, you'll result in fewer clusters, but it is not a one-to-one ratio. Some of the previous studies done with affinity propagation is affinity propagation was applied to the Netflix library in order to identify the most representative movies of Netflix. So basically what they came up with were 9 movies that you could watch on Netflix and you'd be set. Other studies done was taking a group of photographs, images of people's faces, and identified like and similar faces. And then finally, it was applied to American landscapes to identify the most representative American landscapes. That study was called From the Redwood Forest to the Gulf Stream Waters, Human Signatures Nearly Ubiquitous in Representative U.S. Landscapes. The goal of this study was to objectively identify signature landscapes of the U.S. This is very similar to my study, where I attempted to objectively identify signature socioeconomic locations of the U.S. The purpose of their study was to aid into ecosystem management. They used land use, land cover, and satellite imagery as their input data. Their results were 17 distinct landscapes. And in the 17 distinct landscapes, they had 17 exemplars shown in that image. An interesting insight from their results is that in the majority of the 17 landscapes, there was human signature in almost every example. So that went to show, I wanted to point that out to show that using affinity propagation, sometimes you result in interesting findings. Okay, moving on to my methodologies. The first thing we did was download US Census data. We used 2010 census data, and then 2008 to 2012 5-year American Community Survey data. We did it, we downloaded them. Zip code tabulation areas. They follow pretty closely to US postal zip codes, not exactly. They're actually made up from census block groups. And then we took 40 different attributes from the categories. I listed these at the beginning of my presentation: population density, age, gender, race identity, educational attainment, family size, household size, employment sector, income, marital status, nativity and place of birth, and then language that's spoken at home. Next, we formatted the data. We took the null data values. We either replaced them or removed them. And then the z-score for each variable was calculated in order to standardize the data. This was necessary in order to create a dissimilarity. Before we created the dissimilarity matrix, we ran a principal component analysis. The purpose for doing this was first reduce the data size. We were able to reduce the data size by 35% while maintaining 95% of the information. We also wanted to eliminate correlated data. Running the PCA allows correlated data to be removed, which creates a more effective, increased RAM efficiency. Affinity propagation, one of the advantages is it handles large data sets very well, except there still is, when you get to the number of data points that we were using, there is a limiting factor. So it increased RAM efficiency and it decreased overall running time. We created the dissimilarity matrix of how different each point is from every other point in the data set. The size of the matrix is exponential to the number of data points, so we used 32,000 zip code tabulation areas, resulted in just over 1 million pairwise dissimilarities. So this is one of the main reasons why we chose zip code level. If we tried to use block group or anything smaller than that, it would have gotten up to 5 million, 10 million different pairwise similarities, which was too large to handle. As you can, it's on the next slide. To create the dissimilarity, we used a negative weighted Euclidean distance between z-scores and n-dimensional space. The principal component analysis resulted in 26 components, and we weighted those and then calculated the z-score, or the negative Euclidean distance. So we ran affinity propagation using an R package called AP Cluster. Affinity propagation is also available with the software Matlab. We chose the R version because we felt like it ran a little bit more efficiently, and I was just more familiar with R. The approximate runtime for this was 20 hours using 50 gigabytes of RAM on a 3.5 gigahertz current Xeon processor. So this gets back to the reason why we use the PCA and why we use zip code. We didn't have the hardware to run anything larger than that. One of the disadvantages of affinity propagation, though, is it does only run on one processor. That's why it took 20 hours. There are versions out there. I have seen studies where people have come up with their own affinity propagation program that uses parallel processing. None of those are available to the public, and I think they're more oriented specifically for their study. Hopefully in the future they'll get a version that is parallel processing. Finally, we mapped with the results, and that was the fun part of the study. And we're getting on to the results. It resulted into, our result had 22 unique clusters and exemplars. It wasn't surprising, it was expected, but many conventional regions, many preconceived notions that we have about regions of the US appeared. Here's the resulting map. As you can see there, it looks mixed at first, but there are regions that stand out. Some of them that I would like to point out is there's a strong concentration in the south. In the southwest, we have this large group right here. And the borders of the zip code tabulation areas I turned off because if I had them on, it would cloud the representation. So, let's see. Even small areas of this, that's probably about 3 or 4 different zip codes. So it was really cool to see that that a lot of the zip codes that were near each other fell within the same cluster. It's harder to tell because I don't have the borders on, but again, even these smaller areas are made up of 4 or 5 different zip codes. So other regions that I would like to point out is, so as I mentioned, we have the south right here. We have this tannish area that appeared to be part of Appalachia, but we think it's a little bit more than that too. I'll get into this right here, but Hawaii had a significant result. It resulted primarily in cluster 6. Even up here, originating in Washington, D.C., coming up to Boston, there seems to be a pattern right there. The first one that I'd like to look at is cluster 10 and 18, which we deemed the south. Some of the interesting factors about this one is these 2 clusters had, one thing to note actually right now is when I'm referring to some of the data, I'm referring to the exemplar location, okay? The exemplar locations are the most representative points within the data set, but they are not the averages. So you want to understand that there were a couple clusters that had some interesting characteristics, and they fit closely to the averages, but not quite. So I just wanted to point that out. So cluster 10 and 18, they had the highest Black or African American population. Not surprisingly, cluster 18's exemplar was found in, that was Lafayette in Louisiana. Number 10, that was found in Columbus, Ohio. And that was an interesting thing about 10 and 18, is that yes, a majority of this cluster was found in the south, but these clusters were also found in Detroit, south side of Chicago. Again, that's Columbus, Ohio. So they were found in the inner city as well. Cluster 22, the one that I mentioned that had a strong concentration in the southwest, except its exemplar was found in Alaska. The US Census for race, they group American Indian and Alaska Native together. And so unsurprisingly, this had an extremely high percentage of the population of American Indian Native Alaska. So the exemplar itself right here had a population of 97.2% with the race American Indian and Alaska Native, while the average for the cluster was 91.2%. Cities emerged. A really interesting result was that there were clusters that seemed to be only in cities or suburbs. I labeled 1, 2, and 6 suburbs because these didn't, they weren't they didn't result in the actual city itself. I wish I had a zoomed in picture here, but Detroit, like Detroit, inner city Detroit is more right there, whereas this is just on the peripheral. Also Chicago, the band that I mentioned from Washington DC all the way up to Boston has a lot of these clusters. And the defining characteristics of these clusters was that exemplar 1 and 2 had the highest income or percent of population with an income over 200,000. They also had the highest percentage of population with a graduate or professional degree. I know those two factors are oftentimes related. Cluster 6 was interesting. Cluster 6 had a very high Asian population, but it also had a very high, the census, they group, when it comes to language spoken at home, they grouped Asian and Pacific Islander together. So I think that had a strong influence on why Hawaii was grouped primarily as Cluster 6, is because of the language. And then, along with cities, rural areas tended to fall within 4 clusters. Clusters 5, 7, 12, and 13 all were located primarily in rural areas. As you can see, that's Minneapolis right there. There's holes where a lot of cities are. The interesting about the rural areas is these clusters, or the exemplars from these clusters, they were pretty average. So across the board, they didn't deviate from the mean in any one factor. They were basically average. There were some characteristics. Cluster 12 seemed to have a higher white population, I think. Yeah, slightly higher white population. Cluster 5 has a higher middle-aged population. Cluster 13, the maroon, they had a higher, I called it the retirement age because it was 65 and older. They also had a smaller family size. Family size didn't seem to play that big of a factor in some of the cases, but in this case, having a small family size seemed to have an influence in separating it from other clusters. Finally, we get to the one that I kind of deemed Appalachia, but it's also more widespread than that. This cluster was very similar to the South, except instead of having a high African American or black population, this cluster had an extremely high white population, an extremely high English-only speaking population, and an extremely high non-foreign born population. And then, again, another 2 clusters that appeared to be highly influenced by race was cluster 14 and 21. They had the highest Hispanic or Latino population. Cluster 14, 73% of the population was Hispanic, and then cluster 21, 55.2% of the population was Hispanic. And not surprisingly, the majority of these are found along the Mexico-US border. And a lot of the factors were related, so not surprisingly, these 2 clusters also had the highest Spanish-speaking population and the highest foreign-born population coming from Latin America. So overall, I found that race, or race identity, language spoken at home, income, and educational attainment were the highest factors that played a role in separating the US into 22 different clusters. Again, I didn't go through every cluster. That's something that I hope to progress with this research, is a lot of analysis can be done and further research can be done on these results. One thing that I do plan to do is to do a spatial autocorrelation on the topology of the clusters to see how connected the clusters actually are, because again, we're expecting, like with Tobler's law, that near areas should be more related. So we're going to actually try and do that. And then, so in conclusion, 22 clusters with 22 exemplars were found. The exemplars and clusters were based on an objective method. The exemplars can be uses ideal sample locations for future research. This method is scalable. So what that means is we can repeat this method at a statewide level if we wanted to. We could do it like, we could take Michigan, for example, and we could run it only on the zip code tabulation areas of Michigan. We could even do census block groups of Michigan. It's easily repeatable because we wanted to add attributes or subtract attributes. You could easily do that. And then finally, what we discovered from this study was that the United States is a very diverse and heterogeneous nation. So, any questions? Yes?
So I think it's very interesting research. I actually read the paper you mentioned, the land use signature paper you mentioned before. So I have a question. So do you have some criteria, like do you set a threshold to generate this 22 groups, or it's just generated automatically through the software? I mean the 22 groups you generated, 22 groups.
Yeah.
Did you set some criteria or threshold to, or it's just?
Not well, we used Affinity Propagation. That was the clustering algorithm. We set the preference value, and our initial preference value that we used actually resulted in over 200 clusters, which is even more of a signifying fact of how heterogeneous the US is. Our goal for this study, just looking at previous researches, was to get between 20 and 40 clusters. So as I said, like, you can adjust the preference value to influence the number of clusters, but it's not a one-to-one ratio. Like, I did not set 22 clusters. We played around with the preference value, and we decreased it until we got to 22 clusters, which we thought was a reasonable number of clusters.
I like what you've done here. It's very interesting. Now, you mentioned that it's been used for marketing, or at least the opportunity for marketing.
Yeah.
Where else would you see the use for this type of data?
So marketing, or like looking at like government policies, like if there are areas or locations where government policies seem to be successfully working, you can look at that area, you can find what cluster it is in, and then look at other areas within the same cluster, and then try out like that government policy there. Or one thing, like universities could use this as, is for like college recruitment. They can take where all of their like incoming freshmen are coming from, and if they seem to be coming from like a particular area or location, whatever cluster that is in, they can look at other areas of that sort and maybe try and have more heavy recruitment from those areas. Like, does that answer it?
Yeah, it's now your exemplars are not an average as you indicated.
Right, correct.
Are you looking, I guess they kind of create their own region. Are you looking at this regionally though at all? Since it isn't really an average, is there anything regional about this that you saw?
As in, well, part of this, the goal of the study was in the actual clustering, we did not use any spatial data. We just used the socioeconomic characteristics. And then what we wanted to see is once we mapped the results, were there any spatial patterns there? And from just initial look at the results, like you can see that there's a clear pattern going on, at least like in the south in particular regions or particular geographic regions appear to be in certain clusters, such as like cities. Like if we went back to the city slide, like the orange isn't as widespread as say the yellow or the red cluster.
Okay, yeah, it'd be interesting to see a breakdown of what each cluster meant, because obviously the blue that you
yes, yeah,
Native American population, and Yeah.
and Alaska Native.
Okay.
That was the blue cluster. Yeah, in my paper I go into more detail and breakdown of each cluster due to time restraints. I didn't get into it in the presentation. But yeah, that's another thing too that I would like to do is further along the research is to look more closely at each cluster and what makes up and what defines each cluster and why they resulted in the way they did.
Would you be able to use the same methodology on data from, say, 50 years ago?
Yes, if the data was there. Yeah, yes.
That would be fascinating, I would think.
That'd be really interesting. Yeah, because we were thinking about that too. And that's the thing too, is like in the future, like 2020 census, we could do it again and see how it changes, or the exemplars are going to move around and see if anything's going on there as well. Yeah, if the data is available, you definitely could repeat it.
Because what strikes me is you've got two clear regions. You've got the south of Appalachia, and then you've got the blue region out there, which I think is the Navajo-Hopi area, but not much else. And I wonder if you'd have more clear regions 50 years ago.
Oh, right. That's yeah, because people moved around less. That would be really interesting to see. Another thing which I wish I added to the presentation is when you zoom into cities, you can kind of see up here with Detroit, or actually Minneapolis is a good example. It's kind of layered. Like you have like your inner city, and then you have your outer suburbs, and then you almost have an area that we kind of thought of as like the commuters.
Edge cities.
Yeah. Yes. So yeah, there's a lot that can be done with the results that we're still hoping to do. And it's cool to see too, or it's interesting to see that the patterns, the cities, a lot of cities have the same patterns, which was interesting.
All right, well, thanks, Ryan.